Page 96, what we left is the people when they go to high altitude, go to high mountain, okay, what happened to their to their ventilation rate, okay? So in short term, okay, when the people go to the high ventilation, high altitude position, they will have hyperventilation. So that means a very fast breathing rate and also very deep breathing depth. They will breathe faster and deeper because they need more oxygen. Because in such a high area, high land area, there's less oxygen supply, right? So you need to breathe faster in order to get more oxygen. Okay, so and then at the same time, higher heartbeat or higher the stroke volume. They need to pump more blood out of their heart each time in order to get more oxygen to their tissue cells. Okay, so this is like the short-term adaptation if they go to the high altitude. Okay, there's less oxygen, so they need to breathe faster and also pump more blood out of the heart. But if you stay there for a longer time, say for example you do some training for 3 to 4 months, then you will have developed more red blood cells in your body because you want to carry more oxygens to your blood tissues, to your tissue cells. So you will have developed more red blood cells, make more red blood cells in your body. At the same time, you will have more capillary network in your lungs, and also in your tissue cells. So you will have a very efficient exchange of gases.
How come have more red blood cells?
Because in the area is lacking oxygen. So you need more oxygen. You need more oxygen to your body cells, right?
Where do we produce red blood?
In your bone.
From bone marrow.
From bone. Okay, so you have more red blood cells to carry oxygen now, so it can increase supply to the tissue cells. Right? So also increase the density of the capillary network, so it can increase the exchange of materials, exchange of gases, make it more efficient. In the past, they asked you before high altitude training whether it's good or not. Okay, for some competitors before the games. Okay, so they will be sending people to the high altitude such as Sichuan. Okay, before they have the Olympic Games. High altitude training, so you can make them temporarily have more red blood cells in the body. Then they can have high oxygen carrying capacity before the competition. So that's why they will perform better. Okay, there's a belief like this. Okay. Next page we summarize some questions. So first of all is the problem that people may encounter when they go to high altitude. Problem, okay, they encounter the partial pressure is going to be lower at that position, right? So that's why they cannot be fully saturated this time. So and also tissues may not get enough oxygen, so they will have high altitude sickness. That means they will feel headache, they will feel fatigue. Okay, so they need time to acclimatize. So by having high ventilation rate, more red blood cells. So this is the general issues and also how your body will deal with it. Okay. The next one, explain how body acclimatizes to the high altitude. So in terms of short term, high ventilation rate. Okay, in terms of long term, you can say more red blood cells. Okay, more red blood cells. Suggest one more long term adaptation. Capillary network increases in density. Okay. The next one is also suggest what changes to hemoglobin in order to help better adapt it. Because right now there's less oxygen, we need to increase the affinity of oxygen. So we need to shift the curve to the left. We have the ball shift shifting to the left. So it means that at the lower partial pressure, you can already saturate your red blood cells. Okay, so shift to the left. So if it shift to the left, what happens? If it shift to the left, at a lower pressure, you already saturated to 90%. So you don't need to raise a very high pressure of oxygen in order to get it highly saturated. In the environment, the oxygen pressure is already low. There's few oxygen in the high altitude. So at such an environment, we can also fully saturate at the 90%. Okay. Get the notes. If you shift to left, you remember whenever it shift to left, it will increase the oxygen affinity.
Uptake. 还是 release.
Increase oxygen affinity. That means it's get easier to attach to red blood cell to hemoglobin. So it means it's harder to release. Opposite.
Easier to uptake.
We want to take up more oxygen first. In that environment, the partial pressure of oxygen is so low, we must increase the oxygen affinity first.
Induced confrontation change 是在哪里有？
Conformational change. The induced means it's affected by the environment. So the conformation, that means the structure of the red blood cells or the hemoglobin will change. So it can make it more adapted to the environment with such a low partial pressure of oxygen. So it can increase the affinity. We want oxygen to attach more quickly, so we must change the structure. That's the meaning of conformational change of structure.
Okay.
So that it will shift to a level. Whenever it shifts to a left or right, it means there must be structural change. Okay 嘛？係嘛？ Whenever you shift to a left or right, you have to explain because of conformational change. Okay, all these are due to conformational change. That means the structural change.
What induced the conformational change?
The low oxygen pressure in the high altitude. Okay, induced means due to the environment. Okay, it's affected to change.
Okay.
Page 99 is the recent question. Talking about high altitude training. Discuss high altitude training for athletes. Okay, so it actually can improve their performance because there will be more red blood cells in their blood. Okay, especially when they in competition, they can have more blood supply to the muscle cells. Okay, more oxygen can be transported, improving metabolic processes. Okay, efficiency. And the disadvantages is that maybe they have altitude sickness. Okay, not all the people can adapt to the high altitude suddenly. Okay, so the effect may not be immediate because you need time to adapt to the environment to build up more red blood cells. Okay, it takes like 3 to 4 months at least. So you have to go to high altitude. Okay, like half a year before your competition.
But can we eat some pills to overcome that?
Yeah, you can eat some pills to overcome, of course. But of course, it's unfair to the other competitors, right? Who may not be able to train at the high altitude places.
But people actually go to high altitude with their
oxygen tank.
Oxygen tank yes unfair you can discuss some issues like this. Okay. They asked you already in 217 November. Okay. The last part we need to go through is page 106. The diseases that will be brought in lungs. Okay. There's so many areas. Okay. The last thing before we discuss the diseases is about the lung tissues. We have type 1, type 2. You should know these are the topic 6 items. Type 1 pneumocyte and type 2 pneumocyte. Type 1 is the alveoli wall. 90% is type 1. Type 2 is the cervicant cells. They produce the cervicants. They produce the moistures. Okay, make the alveoli wall moist. Okay, so it will facilitate the oxygen dissolve. Okay, or carbon dioxide dissolve. Make sure you know the meaning or the function of type 1, type 2 pneumocyte. Okay, cervicant. And also the cervicant can reduce, can prevent the wall from sticking together. Okay, when you inhale or exhale. Okay, prevent the collapse. Okay, of the alveoli. And you need to also remember, apart from the type 1, type 2 pneumocyte, we have the capillaries surrounded, right? Dense network of capillaries surrounding the alveoli for fast exchange of the gases. Okay, very close to pneumocyte. Okay, so and also oxygen, carbon dioxide gas can diffuse quickly. There's a short diffusion distance. Okay, and the blood flow is moving. Okay, the blood is moving, so it can always maintain a deep concentration gradients. For gas to diffuse. Okay, so this is just the type 1, type 2 and also capillary network to describe the lung tissues.
This is inside the lung, right?
Inside lungs, alveoli, inside the alveoli.
So capillary is actually around
surrounding, okay, surrounding, okay. Next page.
To do
next page X, Y, okay. You try to see X, Y, what's the X, what's the Y, what type of cell is X, Y? Y should be the blood capillary, right? Y. You can say the blood capillary, the blood capillary wall. So we say the.
呢條俾你睇下。
哇！就成日打仗咁嗰啲，同埋綠色窩機啊！喂 Y capillary wall. So capillary wall you say capillary wall, okay? The capillary wall, okay?
So endothelium cell.
If you can remember endothelial cell. Capillary wall, the easiest word you can describe.
真的。
X 好 for X 唔係好㗎。
Shocking 啊
Electric
So
shock
far away.
都係打完仗啦，人哋你唔好叫啊！喂，X，what is X？X is the Taiwan nucleoside, right？係嘛 ？Obviously, one X is the Taiwan nucleoside because it's the alveoli wall，係嘛 ？Taiwan nucleoside, OK？And P-N-E-U.
Yeah, how do you know type 1, type 2?
喂，嗱，because most of the surface in the alveoli is Taiwan nucleoside，係啦 ，OK？Type 2 is just a very a little amount of type 2 there to release the
But type 2
surface.
is also on the surface. So.
Yeah, on the surface, but obviously we can't see type 2 here because most of the layer is so smooth, right?
Okay.
It must be like the alveoli wall for gases exchange. 係啦，OK，得啦，Taiwan nucleoside 係啦。咁 if you're unsure, you can just say nucleoside 咯。OK，if you're unsure Taiwan or type 2。OK，好。
So type 1
Right.
nucleoside is just like
90% is Taiwan.
Okay, just like
10% is type 2.
It's like a
Type 2
membrane.
係啦，yeah, type 2 will be you see here, that one you see picture here.
係
Type 2 suddenly there's a light projection, right?
like a bomb.
No, it will release the cervicant. But most of them 係嘛，all these part, okay? All these part are Taiwan nucleoside. Okay, most of the surfaces are Taiwan.
But they produce surfactant to make it moisture because
To make some moisture, yes.
Of fasten up the reaction of diffusion.
Dissolving the gases, facilitate the dissolving of gases, and then second time prevent them from sticking together, right? 係嘛？Prevent the surfaces of alveoli wall sticking together when you exhale 係嘛？The gases. We mentioned that in topic 6 already 啦。OK， 好嗱，咁啊，the last part page 108 is about the disease. The disease, OK， 咁啊，然後咁 emphysema. Now we mentioned this word before, OK， 咁啊，in topic 6 emphysema, but we didn't really discuss in details. In topic 6 we only mentioned in emphysema there will be a decrease in the surface area, OK, because you see in the picture, is that they will have breakdown of the lung tissues. Okay, they will break down the alveoli tissue, so there's more airspace, less Taiwan nucleoside. Okay, they break down the tissues in the alveoli, and then there will be less surface area for gases exchange. Okay, so what happens is they will have lower total surface area, so there will be slower gas exchange. Okay, degradation of alveoli wall. We will discuss how does it degrade the alveoli wall in the next paragraph. This is the symptom. They will find difficulty in breathing because there will be less lung tissues. There's less surface area for gas exchange, so they feel harder to breathe in now. Okay, this is the problem of emphysema.
Elasticity.
Elasticity. Yeah, we will talk about elasticity. Okay, because you less elasticity, there's less elasticity because there's less lung tissues. Okay, that's breaking down internally. Okay, so how do we break down the lung tissues? We have enzyme called elastase. You can see here elastase. Yeah, in the third paragraph, elastase. Elastase is actually produced by some phagocytes. Okay, there are phagocytes inside our lungs. Okay, they produce elastase. Elastase is the enzyme to break down elastin. What is elastin? Elastin is the component of alveoli wall. Okay, phagocyte produce elastin. Elastin break down elastin. Okay, so without elastin, your lung tissues, your lungs will be less elastic. Do you understand? Okay, this is the idea. You ask me, why will the phagocyte suddenly produce elastase? You know that breaking down the elastin is not good because they see information. Okay, they see germs, they see bacteria. Okay, they see this harmful substance to your body. So they produce some enzyme to protect you. Okay, it's from a good purpose, but they do it in a very badly way. Okay, they do it in a very bad way. Okay, as a part of inflammatory response. But you need to understand. Okay, usually.
Where's the germs and stuff coming from?
From your inhaled air. Inhaled air may contain bacteria, right? May contain virus. So your body senses that, then it will do inflammatory response by producing elastase. Elastase will break down the elastin. That's all. Okay. Elastin broken down, then what happens? You will have less surface area. Okay. So you will be having difficulty in breathing. Okay. But usually, your body will have a protein called AAT. Just heard of it. Okay. To inhibit the elastase function. Okay, so normally don't worry. Okay, so only need 2 bacteria go into your body. Okay, it will not produce elastase because we have some AAT protein to inhibit the elastase function. So usually you will not have any problem. You will not have easily broken down in your elastin. And you need to understand when you smoke, okay, the smoke particle will inhibit AAT lah. Okay, but when you smoke, it's another story because AAT is inhibited. So without the AAT, your elastase cannot break down elastin. Okay, say, 即係嗱 previously I say elastase will break down elastin 啦。OK，
And AAT
係啦，咁 AAT 咧 ，AAT can inhibit AAT can inhibit this process. Okay, but you imagine, but if you don't have AAT, then can it be inhibited? No. So what can make AAT be removed? Okay, the smoking particles, the tar, can remove the AAT. And then you're going to start having the elastase breaking down elastin. So for those smokers, okay, they will have a high chance to have this disease of emphysema. Okay. Of course, another reason is due to
coronavirus.
Hereditary deficiency. Okay. Another reason is going to be the hereditary deficiency because your body cannot make AAT. But this is really a smaller proportion of reason. Okay. But major reason is due to smoking. The chemicals, okay, can inhibit AAT. If without AAT, your body cannot inhibit elastase function, then your elastin will be easily broken down. Okay? Do you get it? Do you get the point? So what is the treatment for these people? Okay, they may need oxygen supplementation. Okay, maybe. Okay, they need to do some pills. Okay, bronchodilators. They spray some bronchodilators to make them make the bronchial muscle relax. Okay, and then they widen the trachea, widen the bronchi, so air can go down easily. Okay, so we can only take some pills, okay, to make you breathe easily.
Corticosteroid.
Or maybe you can do some enzyme inhibitor, okay, do some surgery to deal with that. Okay, we can do the summary on the next page, page 110. Now, outline the main changes in the lung in emphysema. Alveolar breakdown, you can briefly discuss like this. Okay, don't need to mention elastin, and AAT. Alveolar breakdown, okay, causing more air space, and the reason is because of losing elasticity of lung tissue. You know that elastin is broken down now, so you have a loss of elasticity in the lung tissues. Okay, so what is the treatment? Treatment is supplemented oxygen, bronchodilators, inhale steroid, or maybe lung surgery. Okay.
Inhale steroid.
Steroid, but maybe some pills, okay, to make it relax. Okay.
Where can we also find elastin?
Elastin? Elastin usually in your lung tissues.
In our the skin or have elasticity.
Collagen, so majorly, there are some connective tissues, some soft tissues. Okay. Maybe near tissue cells for
in muscle
exchange.
tissue.
Elasticity tissues. Okay, you should know that in our artery, right, we also have elastic tissues. Okay, but we're talking about specifically for our lungs, for our alveoli now. Okay. For option we're down to here 啦。
得唔得都要個 revision 啊？
OK， 你要攤敗啊！Page 4咧，first of all you need to know the xylem vessel, phloem vessel in brief. Okay, in brief you don't need to remember all these. Okay, in details.
Different between
phloem and xylem. You need to know that they're called vascular bundle, vascular tissues. So majorly xylem, phloem. Later we will have one more called cambium. Okay. On the next page we go through the component of xylem first. Okay. The xylem can be composed of the first one, vesicle element. Okay, and then trachea, fibers, and parenchyma cells. So there are 4 types of components in xylem. We go through the first one first, xylem vessel. Okay, so vessel, they will be having a vision elongated cells. That means they are a bit longer, right? Okay, they're longer with vertical column. That means in the middle there's empty part. Okay, end walls have lost the cell content have lost. N1 means that the plant, okay, they're column, so they already removed the cell wall here. So this part can allow water to go through.
Oh, so
okay, so you remove the hollow tube, okay, you remove the upper part and the bottom part, the blocking the fluid to move, okay. You remove the end wall already. You also remove the cytoplasm, nucleus, mitochondria, corpus, all removed. So that's why they're actually the dead cells. Okay, all these three features can enable it be a hollow tube.
Oh, they're dead cell.
They're dead cell. They are just for support and transport of water. Okay, mineral source. Okay, so they are all going to be dead cells. All the things are lost. It's just a tube. Okay, basically just a tube. Okay, and in order to make it stronger, we try to make it lignify. Okay, to prevent collapse, to give mechanical support. You need to know this word, lignify. Lignify. Okay, at the same time, we have some pit. I will tell you what is pit. Pit means that there are some holes. Means holes. Holes in the silent vessel. We will see the picture. Okay, there are some holes allowing water transport. Okay, or allowing water to go in. The holes, yes. Okay, it has a gondola shape there. Okay, allow close pack. The next one, okay, is called trachea. Trachea is similar to silent vessel, but trachea is usually smaller in size. Okay, it's also similar to the silent vessel, which is hollow tube. Okay, elongated cells, and lignified, strengthened. Okay, they look very similar. I'll show a picture on the next page. Trachea usually smaller, weaker than silent vessel. Okay, the next one is fiber. Fibers. Okay, some connection between the silent vessel and trachea. Some fibers. They also lignify. And the last one, parenchyma cell. You need to remember this word. Parenchyma cell usually for storage. Right? The parenchyma cell is for storage. For storage. Okay. For storage of starter. Storage of some food. Okay. We show you the picture first. Page 6. The page 6. So we have just mentioned xylem contain 4 components. Component 1 vessel. Component 2 trachea. Component 3 fibers. And then some parenchyma cells.
Okay, Mr. Bronson, which part of the plant are we talking about right now?
Xylem.
Xylem, so it's just the stem.
Silent vessel. They contain different tissues. Okay, different type of the tissues. We have the vessel tissue. We have a trachea tissue. Fiber and cells. They mix together, becoming a xylem. Okay. Xylem is you can say it's an organ. Okay. Which contain different tissues are mixed together. You see the vessel. The vessel is a hollow tube, right? The end walls have removed. You don't see any coverage. It will be a hollow tube, allowing the water to go up. Okay, from the root to the leaf. And you also see there are some holes, right? Some pit hole. Okay, some pits, some holes, allowing the water to go out. Okay, at that point. And then trachea. The trachea, is similar structure to vessel. But when you compare the size, okay, the holes is actually smaller compared to xylem vessel. Okay, trachea, the holes is also smaller, but the same function with vessel, which is used to transport water. Okay, from a little comparison, on the above table, you see that the resistance in trachea is larger. The resistance of water flow is larger because the hole is smaller. Okay, and the xylem is going to have a wider hole. That's why it's going to be smaller resistance.
Okay.
And also you will see for xylem, it's usually appearing in the angiosperm, in the flowering plant. That means the higher class of the plants having the xylem vessel. Okay, the lower class, okay, lower class will have trachea. We have trachea. Okay. Fibers. There's some fibers here for some connection. And finally, parenchyma cells. Okay, for storage of starch. Remember, don't need to recite all features, but remember all the big terms and their standard function, general function. Is that okay? Okay. Remember the picture. On the next page, I quickly show you the xylem and vessel at the same time. On the right hand side first, right hand side we have the U, right? Can you see? They have a lot of lines, right? Those lines are called the lignified walls. Lignify. Okay, so we call this the xylem vessel. Xylem vessel. Okay, VSSEL. Xylem vessel. OK。
哇，这个 picture 真的是 IB 考試 picture。
You are usually they will show you this type of
low quality picture.
OK, silent vessel. You can definitely tell because all these lines are called the lignify. They give the lignify wall to give the mechanical support. OK， 好，咁啊嗱 on the left hand side can you see T? T we have suddenly some region very dark, right? Some region very dark. OK, what are these? Later we'll talk about that. That is called sieve plate. Sieve plates. In the 412 so for basically 即係 for R 應該係 R tube 啊，咁啊 R tube。You mention R 先 ，R can you see here this part？ This part 係嘛 ？Okay, this is a dark line, right? There's a dark line here. This dark line represents the sieve plate, 係嘛 ？So when you point out that we call this the sieve tube element. Sieve tube element. Later we will discuss, okay? The 412. So I can say in this picture, generally speaking, on the right is xylem, on the left is the 4-1. Okay, and the 4-1 will contain sieve tube element. Okay, how do I tell? Because suddenly there is a line. Okay, this is called the sieve plate. Now I think you heard of this word, right? Sieve plate. Did you have sieve plate? Okay, adjacent to the T, adjacent to the sieve tube, usually I call the companion cell. Companion cell. This is a typical structure in the 4-1 yeah. Companion cell. Okay, companion cell. Okay, and what going to be the S? Okay, S is usually the standard parenchyma cell. Okay, parenchyma cell. Okay, for storage for storage. In exam, of course, they will not ask you in details. They will ask you which side is xylem, which side is 4-1. Obviously, you will see right side is xylem, left side is 4-1.
Which side is 4-1?
4-1 is on the left. Because I don't really see a lot of lignify wall. Xylem will contain a lot of lignify wall to give you a lot of dark lines, horizontal dark lines. Okay? We will see this picture more. Okay? We finished the xylem, which contains 4 types of tissues, cells, vessel, trachea, companion cell, and fibers. We quickly go through some MC about xylem. Okay, let's see if you clear with the function of xylem. Angiosperm. If you still remember this word, it's about flowering plant. So what is the function of xylem in flowering plant? Physical support. Passive transport for water minerals. Okay, active transport of carbohydrate is not related to xylem. It's related to 4-1. So 1 and 2.
But it does do the storage.
Storage. You can say storage, but this is about transport. Okay, transport of carbohydrate must be done in the 4-1. Yeah. Okay, the next one. What is the role of xylem? Xylem is to contribute to the plant support, right? With the lignify wall D. Okay, 2007 how do long woody terrestrial plants support themselves? Long woody, that means they don't have wood, right? They don't have a lot of dead cells. They don't have a lot of dead xylem. So they will be using turgor pressure, cell turgor pressure. Usually the long woody plants they have fewer xylem. Okay, so that's why you will not see, first of all, you will not see the concept of xylem here, because they want you to understand between each plant cell there is turgor pressure, right? Because the plant cell contains a large vacuole. Turgor, cell turgor. Do you remember? Plant cell, there's a vacuole. In the plant cell, there is turgor, right? There's cell vacuole, and the vacuole contains water, and the water can give pressure. Give the shape of the cell.
To hold the shape,
yeah, that's why it will give support. It will give little support for those non-woody plants.
So woody means they have that cell.
Or just like those plants non-woody, these plants, right?
A fake plant.
Real high.
Oh, real high.
Okay, they don't have wood, right? You definitely can't see the wood, right? They can see the so-called connection between the leaf, right? The turgor pressure, you can squeeze it, and when you squeeze it, I think you will feel that some water comes out, right? In those plants, because they use the cell turgor pressure to give the support.
Do they have xylem?
They have xylem, but of course, compared to the dead wood, okay, this is not the major way to give support. 係啦，they
But
use
then
cell turd.
trees has like the dead wood, right?
Yeah, of course, yeah, the woody plant
Okay.
they have a lot of xylem, right, and also dead cells to give the support. Okay, compared to the woody plant and non-woody plant, non-woody must be shorter, right? They can't build so high. Okay, they can't build so high because they don't have a lot of dead cells, dead xylem to give the support. Okay, 好 the next one. Which of the following help supporting terrestrial woody plant? Okay, now for woody plant, we have the xylem, right, to give the support. Turgor pressure also can do it, okay, but phloem will not. Okay, phloem is not giving you the function of support. So 1 and 2.
MCQ
It's okay.
Yeah.
You see the bottom picture lah. You see vessel element we have discussed already lah. Checked. They have the lignified wall. They have the pits. It's okay. This picture is clear, right? To show you where is the silent vessel, where is the checked. Obviously here, right? This is the vessel element. And then on the left, can you see on the left, parenchyma cell and then phloem sheath tube. You can tell, but we were not just focusing on phloem. So we don't talk about the left side. We're just focusing on the right side.
That's the para.
Yeah, obviously these are like the parenchyma cells for storage. Okay.
It says the mature xylem is dead.
Yeah, that cell giving you the woody plant structure, right?
Which part of this tree is xylem?
Look, if it's a stem, then we will talk about they are in a ring shape. Yeah.
Oh.
Okay. We will talk about that later. Okay. We are not learning the details for woody plant. Don't worry. Okay. We just need to know briefly for the fascicular bundle distribution.
It's just surprising that they're dead. So how can they become dead? Because they develop into a organ more because the structure, only structure used.
Yeah, they give a death shape. Okay, in order to give the support. That's the major function. Okay. Now, page 10. The page 10 we're going to discuss more on the phloem. Now for phloem, they will have also 4 elements. 4 type of substances. The sheath tube, the first one sheath tube, the second one companion cell, the next one fibers, and also parenchyma cell. 4 types of cells to help the transport of carbohydrate, amino acids. Remember the cell type, the first one sheath tube or sheath elements. They're elongated, and they will have sheath plate. The end wall will have sheath plate. So maybe you can see the picture below. Can you see here? This is a sheath plate. This is a sheath plate. This is a sheath plate. Okay, you can see there's a line, right? Because the cells will not be hollow. There are some sheath plate, at the end walls. But don't worry, the sheath plate have holes, so it will allow the substance to move. Okay, maybe you can see a picture on the right side first. This is the sheath tube element. You will see the sheath plate, and in the sheath plate there are holes to allow the movement of the substances. Okay, so remember when you discuss the phloem, the direction of flow will be up and down at the same time. Yeah, so they can allow the movement going up or going down. But for the xylem, on the previous part, it can only allow the movement going up from root to stem to leaf. Okay, make sure you know the difference between xylem and phloem. Okay, you briefly understand the sheath plate. Okay, and what happened to the structure there? You can see a few small mitochondria. You can also see some endoplasmic reticulum. Okay, but no nucleus, no ribosome, no Golgi apparatus present yet.
You have also the dead cell.
Yeah, it's not. This part you can say is dead, but more importantly is the companion cell.
Okay.
Companion cell will help it, will control it. So usually we will discuss in this way. Xylem is dead, but phloem is not dead. Okay. But you can go back to the table. But in the table, I would say nucleus are degenerated. The reticulum is also degenerated. Okay. The ribosome is also degenerated because we don't need them to affect our transport substances. Okay. The major part of the component of the cells, is already removed. Then we also will discuss, there's something called plasmodesmata. You need to remember this word, plasmodesmata. Now, in the option, we have non-tight junction, right? Tight junction is between the animal cells. It's the junction between cells. Plasmodesmata is a common type of junction in plant cells. Now, we can refer to the next page, okay, page 11. Can you see the adjacent is a companion cell, okay? It's really a standard plant cell. You see there's a nucleus, vacuole, okay, mitochondria. And more importantly, can you see the junction? Can you see there's some holes, right? There's some holes between the companion cell and the vessel, okay, and the sieve tube vessel. Okay, it is used for active loading. So later we will learn how the phloem sieve tube transport the substance. We need to upload, we need to put the carbohydrate into the sieve tube by the companion cell. The companion cell will use the plasmodesmata to transport the food into the phloem sieve tube.
Do you get which one is same as tight junction?
This one, these are the similar function to the tight junction, but they are not called tight junction. They are called plasmodesmata.
The junction is in the liver, right?
Yeah, in the human being, Okay, but in the plant cell we will say plasmodesmata. The junction between cells, the phloem sieve tube and the companion cell.
But they have like holes.
Yeah, there are holes allowing.
Cytoplasm goes up.
Yeah, there's end wall. The cell wall is not blocked, right? They can. Of course, they have plasma membrane now, okay? So when the substance moves out from the plasma membrane of companion cell, they can go to plasma membrane of the sieve tube element already. Go in. So there's active loading of substance into the phloem sieve tube. Okay, so the arrow represents the movement of the carbohydrate moving into the phloem sieve tube. The companion cell can help this uploading. Do you understand? Can help the upload of the carbohydrate.
The sieve tube element is this one, right?
Yeah, the right hand side is a sieve tube element. You see
entire is a sieve tube.
Sieve tube element.
Sieve tube plate 是这个。
sieve plate, yeah, sieve plate. There are holes in the sieve plate. Okay, do you understand? The companion cell will help the upload of the substance. Okay.
What's that hole called?
The hole? What holes?
The hole on the tight junction.
Plasmodesmata.
Plasmodesmata.
Okay. You need to know this, okay? Plasmodesmata, okay? I will not say the phloem data because there's companion cells next to it. Okay? Large nucleus, mitochondria. Okay? We will use the active transport, metabolic active. First of all, metabolic active. Okay? So that's why it's used a lot of energy to do the active transport. Okay, fibers, giving some strength, mechanical strength, parenchyma cells, parenchyma cell for storage. Okay, of course the focus of phloem will be these two, sieve tube and companion cell. This is our focus. Okay, you briefly remember the structure, that's fine. Okay, page 12, let's see a question, how they ask you. Okay, when you look at this question, we see sieve tube element, we see companion cell, okay, sieve tube. Cytoplasm, sieve plate, okay? What is the role of this plant structure in the diagram? We know this is a phloem. So the function is the transport of sugar, right? Translocation of sugar, B. It's okay?
What is the function of xylem?
Xylem is the
structure.
For xylem, I can say A. Xylem is A, carries water for transpiration stream. Xylem, okay?
But then phloem is only carrying the nutrients.
Yes, I know. You see the picture below, okay? Especially the bottom right corner. Can you see xylem? Can you see phloem sieve tube, right? Companion cell, phloem sieve tube. Okay. You can see the sieve plate, but there's a line, right? There's a horizontal line. There's some lines in the picture, right, on the left side. These are the lines showing you the sieve plate, so we know they are the sieve tube element. And of course, companion cell is just adjacent to it. Maybe a bit smaller, okay, in the size. The companion cell is adjacent, to the phloem sieve tube. Okay. We are not focusing a lot on the parenchyma cells, okay. You need to understand the focus on each, okay, item. Maybe I give you more clear classification, okay. On top of the table above that, you can read it yourself, okay. It's easy, okay. But I want to do a feature table with you. Xylem vessel, phloem sieve tube, and phloem companion cell. These are the three types of cells we are focusing a lot, okay. The xylem, we do the xylem first. The xylem have nucleus? No, it's dead, so no nucleus, no cytoplasm. Empty lumen, yes, because it's used for transporting water, right. Lignin, yes, lignify. Cellulose, yes, all the plant cell wall cellulose. Sieve plate, it does not have sieve plate. Transport organic solid, no, it's not the major function. Role in support, yes sir. Transport water mineral salt, yes sir. Mitochondria present, no, it's dead. OK， 咁 for the forum 特性 nucleus 咧係 no 嘅 ，degenerator 啊嘛 ，ribosome degenerator 啊嘛 ，OK。living cytoplasm 咧係yes 嘅 ，can still have some cytoplasm 係嘛 ，but you see it's so small right？ So you see the region 係嘛？ You see it's like here right？ It will allow the major 係嘛 region allowing the transport of substances。好 and so that's why we don't say form as dead 咯，係嘛 ？empty lumen 咧 no 嘅。It will still have some mitochondria, okay? It's not completely empty. Lignin in wall係 no. Remember, form sieve tube no lignin, okay? Cellulose, yes sir. Sieve plate, yes sir. Transport organic solid, yes sir. Role in support, no. Transport water, also no. Mitochondria present, yes sir. Form companion cell is really a standard cell. So nucleus, yes. Leafy cytoplasm, yes. Okay, empty lumen, no. Lignin in wall, no. And then cellulose in walls, yes. Sieve plate, no. Transport organic solid, no. Role in support, no. Transport water mineral salt, no. Mitochondria present, yes.
But like when we talk about the lignin in walls,
lignin wall. What is lignin? Lignin, some. So you can say some plant tissues.
They have like ligament on the
Okay. Now this is the lignin, no. 得嘛？即係 some attachment on the xylem. Giving you some stronger attachment. Just like, okay, we have some rubber band, okay, here. Come on, here. Giving you some more support. Lignify, okay?
Lignify.
Giving you some protection, no? Extra protection.
What's that called? Lignify.
Okay.
Lignify wall.
Lignify wall, okay? Maybe you can see some joint here. These are all called lignify wall, You have some circular thickening line here.
Wow, so that's also the lignin.
No, these are called lignify wall. Okay, lignify wall, okay? And also you see the jacket. Can you see? There's some ring. Lignify wall, right? Giving the strengthening power. Okay, lignify wall. It's okay? Okay. Lignify wall is in xylem because you need to give support. But in forum, we don't say it. So forum don't say it's going to be a function of supporting. Okay? Now page 14, okay, we actually have a question about the comparison. Yeah? But can we cross out this first, okay? The question is wrong.
No, A marks.
Sure. Mine is correct, but yours is wrong, okay? Did you see difference in structure between xylem and forum? Yes, okay. Mine is correct, yours is wrong, okay? So, you try to write down first, okay? Outline the difference between structure and xylem and forum, okay? This paragraph is a short question about xylem and forum structure difference. You can say xylem is dead, okay? Xylem vessel is thicker wall, xylem walls are lignified, forum have sieve plate, xylem are wider, companion cell in xylem in forum. These are all the main features we have discussed so far. Are you okay?
Okay.
Okay,好嚟 page 15. The next one up. How are the fluid transported in xylem and forum? 15, page 15. Previous page 15. Okay. How are xylem transported? We want
away
to focus
from the roots.
Away from the roots, going up. But forum is
Doubles.
So it would be the answer. 係咪 D 啊 ？D 啦，OK， 好，the next one 啦。So what is going to help support our terrestrial root deep palm? We've done it 啦。Xylem, turbo pressure 1, 2。OK， 好嚟啦 ，page 16。Let's see a question here. So on this picture, as far as you know, what is 2?
Xylem.
Okay. This is
lignify wall.
This is a stem of long woody plant. OK， 得嘛？ You still have xylem 嘅，得嘛 ？2 is xylem, right? You definitely can tell 2 is xylem. What is 1 啊？
The paramel.
Not parenchyma. OK, parenchyma is right here.
The severe tube.
The sieve tube 即係 forum 係嘛 ？forum sieve tube
Sieve tube.
係啦 ，forum sieve tube
哇，這名字真係。
係啦。But of course you can tell in the middle, right? They are the parenchyma cell. But not important. Okay, parenchyma cell here. 好嚟 the question answer. Wait, what feature distinguish label 1 and 2 label 2 is xylem 2 active transport. No, it's all obviously osmosis, water. Water transport. 2 product of photosynthesis transporter. No, 2 is water transport. 1 movement of materials is result of transpiration. Wait. in 2 we have transpiration. Okay， 咁所以 1 係咪 D 啊 ？There's a higher solar concentration because in phloem we have a lot of sugar. The sucrose is transported there, right? The sucrose is transported in phloem.
咩係 transpiration？
Transpiration. Now what is transpiration? You know that the water will move up along the stem, right? Along the xylem. That's called transpiration. So when the movement of water occurs in the stem from the root to the leaf, because the water is lost in the leaf, in the stomata, so it creates a sucking force. The sucking force is called transpiration pull.
So they actually carry them up, or is there?
Yeah, it pulls the water up from the roots to the leaf because the water is lost there. You need to compensate, right? So water keep moving out from the mesophyll cell. This creates a sucking pull.
Okay. How does it move up from the lumen? It's like going up.
Going up transpiration pull
Okay.
along the xylem.
Okay.
That's called transpiration, but it's not happening in phloem. So C is wrong. Okay. So what is transpiration in brief discussion? This is the movement of water along the stem. Okay, along the xylem. Okay.
By using more forces to suck them up.
Yeah, we will see. Okay, it's like a sucking force. Okay. Page 18. Now page 18. Okay, can you tell me first? Now this is a vascular bundle. Okay. Now from your understanding, which one is xylem? Which one is phloem?
big hole.
The big hole, Can you see the big hole is so thick, right? Because it's so deep, There's darker color band, right? So the xylem is the hole, and then the smaller one is the phloem. The question asks you, will xylem phloem contain structure adapted for transport? Outline differences between xylem and phloem. You can definitely answer this one. OK 嘛？咁啊 ，Can you tell? OK， 我嚟 Part B. Outline properties of water. This is topic 2 question. How do you describe water property? Do you remember you have learned adhesion, cohesion? 係嘛 ？So you have to mention these 2 words, 2 marks. Adhesion, cohesion. Cohesion is between same type of water molecules. Adhesion is between the cellulose of cell wall, okay, of the xylem, and the water molecule.
The cohesion is within water is.
係啦 ，cohesion is same type of molecule. Cohesion between water molecule Cohesion between water molecules. Okay, adhesion
Between water and xylem.
係啦 between your water and the
cellulose.
And cellulose of cell wall of xylem and cellulose of cell of xylem. OK， 好，咁啊，the last one outline the structure of the cellulose that makes suitable for component okay of cell wall. Like you have learned cellulose is beta in chem option we've learned is beta, right? Beta glucose. Cellulose, do you remember, is going to be microfibrile, hydrogen bond between each chain. Do you remember hydrogen bond between each chain? Microfibrile in topic 2. Did you remember?
Microfibrile.
Do you remember the structure of cellulose? Cellulose, they have hydrogen bond between each chain.
Okay.
There's strict chain.
Okay.
There's strict chain. There's hydrogen bond between each chain. Make it strong. Okay, forming microfibrile. These are the keywords you should answer. You see it in the answer part C. 得嘛？1 4教識題啦。Okay, if you can't remember this word, okay. But can you see forming strict chain and then forming the microfibrile, 得嘛 hydrogen bond between the linkage.
Can you draw the chemical formula for the?
什麼？what formula?
Can you draw the
1 4. Like we learn in chem.
Cellulose.
Cellulose. The structure is like this. Okay, cellulose. Do you remember? In chem option, we also see this structure. 有冇做？
什麼
chem carbohydrate 嘛。You keep repeating. 係咯。
Haven't finished that.
好，唔緊要we will revise in topic 2. Don't worry, okay? Cellulose. The key words is strict chain, hydrogen bond, microfibrile. Okay, microfibrile.
Ribose.
Come on, can you see? Underline here strict chain, microfibrile, hydrogen bond. Come on, 2 marks you answer the keywords, it's fine. Okay. Hold on, page 20. Now we already understand xylem and phloem. Okay. So what's the next thing we need to discuss today is the vascular bundle in root, in stem, and in leaf. We need to discuss the structure of root, stem, leaf. Okay. Now first of all, we talk about stems. And the plants we're going to discuss is dicotyledon plant. Okay. Now we are just learning dicotyledon. You know what's dicotyledon, right? In the dicotyledonous palm. Dicotyledon. That means in the seed we have 2 seed leaf. Like in the last stage of palm by we need to discuss the seed. 2 seed leaf. 雙子葉啊 2 seed leaf in the seed. That is called dicotyledons. Okay? And we are not learning monocotyledon. That means 1 seed leaf in the seed. We are not discussing that type of structure. Yeah? We do not need to learn that. Okay? We are just learning dicotyledon palm. In the stem, the structure of xylem and phloem vessel will be arranged in a ring shape. Can you see? This is the stem. There is a lot of rings, right? Each of the components is called vascular bundle. The vascular bundle are arranged in a ring shape. In a ring shape. And when you discuss the structure, okay, I need you to remember vascular bundle. We have xylem, phloem, and cambium. Can you see that 3 words? No need to know the first one, okay? But make sure you know phloem is outer, cambium in the middle, xylem is the inner. Okay, xylem is in the inner part. 2 in the ring. And the cambium in the middle, phloem is the outer part.
So phloem and xylem is actually in the vascular
the whole thing is called vascular bundle. And the vascular bundle is arranged in a ring. Okay, in a ring shape in the stem. Okay? Xylem in the middle, cambium in the xylem in the inner part. Cambium in the middle, phloem in the outer part. Cambium will be actively dividing to produce new xylem, new phloem. We will discuss cambium later in note 2. Okay? And in the outer part we have epidermis. You need to know this epidermis. And then we will have parenchyma cell. Can you see cortex? Epidermis, okay, the surface of the stem. And then we will have cortex. And then in the middle we will have pith. The pith also contains a lot of parenchyma cell for storage.
Which part is cortex?
Cortex is the outer part, just like the kidney, right? The cortex is the outer part, right?
Okay.
Cortex is the outer part, and then we have the vascular bundle, and the inner part is the pith. Is that okay? Epidermis, 表皮係啦，表皮。
Okay. Epithelium.
Epidermis, okay? Now maybe we see one more structure on the next page. We see more clearly. Now, in this picture, we know that this is the stem, okay? Now we have the epidermis. Can you see the first word? Epidermis. Epidermis. Okay? And then in the middle, we will see pith. Pith, okay? In the right middle, we will see pith. Okay. Pith is just the parenchyma cell for storage. For storage. And then we will see a lot of vascular bundle. The vascular bundle is arranged in a ring shape. And the vascular bundle will contain xylem, xylem in the inner part. And then cambium in the middle. Finally, phloem in the outer part. Of course, when you discuss xylem, the main keyword is leaf-like wall. And then phloem, we will say they have companion cell. Okay, they have sieve player. These are the keywords you should remember. Okay, you don't need to know the others. Just make sure you know all these key features.
这是木桩是吧？
对对 ，herb stem.
So like a macro stuff. 这个是 micro.
OK， 得嘛
OK。
好，得。咁on this page now we see some other pictures. Now this is also the stem, right?
So middle 的地方是没有 vascular bundle.
No vascular bundle on the ring shape. On ring shape. 好啦 this is also a stem, and in the stem we will see pith from the inner part, and then we have the vascular bundle, which contains xylem, cambium, phloem. Okay, and then finally we have epidermis, at the outer region. 就係咁 These are the keywords you should remember. 得嘛 ？OK 嘛？好啦 let's see MC 喎，得嘛 ？Page 23. Did you learn this before in pre-IB?
We learn
in IGCSE bio they learn the.
We learn the structure. I know like cuticle. Cuticle 啊
，only cuticle。
cuticle 係 stroma 啦。
開第二包，有冇開呢包？
哦。
我也想吃。
I want tomato food.
好。
為什麼
for page 23 so we have already got the dissection of the plant stem. And the question asks you, where is the translocation of sugar? The translocation of sugar will be in phloem. Which one is phloem?
Wow.
The vascular bundle in ring shape and the outer part of the phloem, right? Outer part is boy 係啦。What is A? What is A called? A is called epidermis.
Cortex.
Yeah, cortex cortex. A is cortex And D is the pith. C is the xylem.
Also, pith is like the paramag.
Usually contain parenchyma cells.
Parenchyma cell. Also, entire is parenchyma cell.
好，你諗下2011啦，the next one which one is going to be correct 嘅？This one is a dicotyledon stem 係嘛 ？A. Now first of all, we will not learn monocotyledon, so B and D are wrong 㗎啦。And we didn't talk about root structure yet 係嘛？This one is a stem. Okay, A 咯。好，嚟 check for. Now check for we have the stem again. Okay, and then what is the function of Y? Y is xylem. Come on, first of all xylem and the function is going to give the transport of water but not transport of sugar, so B is the best. Come on, mechanical support. Okay, now the next question, which one is going to be involved in the carrying solids up the stem? Okay, now for this question 2005 very tricky because the solid that here will not be only just the carbohydrate sucrose, right? We may have some other solid called mineral.
Mineral what? Xylem, no?
So both xylem and phloem, 係嘛？ So 1 and 3, 1 and 3，得嘛？D 咯。OK， 好咁啊，the next page 2017. So this one, of course, begin phloem 係嘛？phloem is going to be boil 係嘛？boil 咯係啦 ，OK。
What's the difference between D and B 啊
？D you may say is like C is xylem 係嘛 for clear， 咁啊 D not really related to it's maybe the xylem tissue cells 係嘛 it's a component of the xylem tissue cells, but B is the better answer, right, to describe they are the phloem cells. Okay, I'm sorry, B is the better answer.
But what's the difference between this circle and that circle?
Oh, they're all the same, yeah. All these circles.
Xylem.
They're xylem.
Okay.
Because they're so hollow, they're bigger, right? 好咁啊 in 26 on page 26, you saw a question about phloem. This draw a plan diagram showing arrangement of tissues in a dicotyledon stem. You can go and draw it out. Okay. 好咁啊 next page 28. So we now discuss the leaf first. Now on a leaf, okay, we will have more layers. Okay. Then maybe we look at a picture on page 29. Now 29 is showing the leaf, okay, section. Cuticle, upper epidermis. The upper epidermis usually are transparent to allow light to pass through to go to the palisade mesophyll.
這個我學過。
palisade mesophyll are closely packed to contain corpus. Okay, and then the spongy mesophyll, will be loosely packed, okay, to allow the air exchange, to allow the gas exchange. Okay, and then we will see the stomata, and then to control the stomata opening, we have the gut cell. Gut cell usually also contain corpus. Well, of course, we have the lower epidermis. And when you look at the middle part, you will see fascicular bundle. Now, when it comes to fascicular bundle, remember we will have the xylem on the upper part, phloem at the lower part. Okay, xylem on top, phloem at the bottom. Okay, and for the structure of the leaf, okay, now you can briefly take a look. Thin fat, increased surface area. Okay, numerous stomata, they have gut cell. Okay, moist surface in the mesophyll cell. So in the palisade mesophyll, spongy mesophyll, they have moist layer. So it can allow the faster diffusion of gases. Okay.
What's the difference between the spongy and the palisade?
Spongy mesophyll and palisade mesophyll. But for palisade mesophyll, it's usually on top of the layer. So the light will go down to palisade mesophyll first. For spongy mesophyll, they are loosely packed. They are the lower parts. So they are usually for gases. Okay, exchange. Okay, for allowing more space for gas to exchange. But spongy mesophyll also contain corpus. They can still carry out photosynthesis. Okay. The major function for mesophyll cell are for corpus, are for the photosynthesis. For photosynthesis. Okay, you need to locate the position correctly. Okay. Any question?
Oh, so if there are airways in the bottom of the leaf, that means they prevent from the evaporation.
You mean for what?
From the stroma. Evaporation.
The stroma is allowing water to go out. At the same time, it's allowing gases exchange. Okay. Now, when you open the stomata, right? Okay, the stoma or stomata. So water will be able to evaporate. Okay, and then diffuse out of the stomata. Okay, so the water will evaporate from the mesophyll surface. So first of all, when you say go out, evaporate, yeah. Okay, and then when you say the water go out, diffusion. diffusion. Okay. So you think about when the water has evaporated, you need to draw the water out from the xylem. You need to draw the water out from the xylem to compensate for the water loss. Okay, so this creates a sucking force from the xylem. Okay, this creates a sucking force in the xylem from the root to pull the water up. This causes circulation. Okay, they can allow the water to go out from the xylem. Okay, to penetrate to the other mesophyll cells.
點解唔係 the spongy mesophyll cell on the top 咧？ They're faster evaporation rate.
Oh my god, usually stomata are more in the lower epidermis.
Okay.
Okay, fewer stomata on top. Okay, because if you have more stomata on top, there will be direct sunlight exposure, right?
Okay.
To cause very fast water loss in your plant cell. Okay, so that's dangerous. Okay, to the plant. Now page 30. The page 30, we look at the dicotyledon leaf. Okay, so you know that EZ is the upper epidermis. EZ should be the cuticle. Okay, what is the function of it? Of course, it's used for the water conservation, cuticle. And then for Y is usually upper epidermis. X is the phloem. X is phloem, then we are sure the answer must be boy. X is the vesicle bundle. Phloem and the bottom.
What's the usage of the cuticle?
Cuticle, water conservation, prevent water from losing. Reduce the evaporation of water, right? Reduce the water loss. Cuticle, protection, reduce water loss. Okay? It's a waxy salt, it's a waxy fluid, waxy substance, okay, on top. Alright, 210, the next one. Which two tissues are photosynthetic? Okay? The photosynthetic, obviously, we would say spongy mesophyll, palisade mesophyll, B. Okay? Any question?
For 2012, what's the X part?
X is phloem.
Phloem. Okay.
Because in the middle there's a line, right? That's called cambium. And the upper part is the xylem. Okay. And then for 2010 November, the second question: mesophyll, palisade mesophyll, spongy mesophyll. Okay.
Okay.
Well, the next one, 2006. Why are there usually more palisade mesophyll on the upper surface? Okay. As we said, upper will receive more sunlight, right? So you have a lot of palisade mesophyll, so you can have more light to be trapped. So B. Okay, the next one. Which one is photosynthetic? So
Epidermis.
the cuticle obviously no, right? Xylem, phloem, they are not for photosynthesis. So epidermis, the next one. So in the leaf, which one is containing chloroplast? 4 must be wrong. 4, okay. 1 and 2 palisade, spongy mesophyll, okay. And then the lower epidermis also contain so 1 and 2 and 3.
Can epidermis also do photosynthesis?
Yeah, the lower epidermis or upper epidermis, they may also contain chloroplast. But usually upper epidermis will not contain.
But the most is in the mesophyll.
Yeah, okay. In the lower epidermis, so say for example in the gut cell, in the gut cell we also contain chloroplast. So gut cell is a part inside the lower epidermis. Okay. But upper epidermis, usually they don't contain chloroplast because they need to allow light to go through. Okay. To go deep, to go penetrate into the palisade mesophyll, okay, or the spongy mesophyll. Okay. 1, 2, 3. 1, 2, 3
Okay.
Okay, 好。得next page of 32 what is 1 what is 1 and what is 2? 2
是怎么做 dissection？ 那到底是怎么
dissection? Maybe you take the electron diagram.
Like this, up and down.
This is the leaf, okay. Leaf is very thin, right? You do the vertical dissection, You do a vertical dissection of the leaf.
But so the leaf and the xylem and the phloem actually link to the stem.
Yeah, of course, yes, they link together. I will show a picture of connection later. The one is the palisade mesophyll. Palisade mesophyll. Okay. 2 is the stomata. Stomata, okay. Outline the function of 2. 2 is the stomata, which allow the gas exchange. Diffusion of gas. Opening. Diffusion of gas. Gas exchange. Okay. We have so far learned the stem, right? We have so far learned the leaf. Right now we're going to go through the roots. Finally, go through the roots. OK， 咁啊 page 34 first. 34 to show you the diagram. OK， you need to label the diagram for a leaf here. Label diagram for distribution of tissues in a leaf. 咁啊，咁 you can tell from the picture below 啦。
For this kind of essay question, if we can draw a picture, it's better to draw a picture. Like we draw a picture, then we say something.
Now, of course, if the question asks you to draw, I mean you must be drawing a diagram.
If it doesn't ask you to draw,
you also need to attach a paragraph. That diagram, just like oxygen dissociation curve, right? You use the curve to help you to explain your paragraph more clearly. But of course, if you think your paragraph and your graph can be linked together, you try to draw a diagram.
Okay.
But it's not necessary in some paragraph questions.
But do biology give you like in real exam does it give you the bonus?
The line paper.
The bonus mark.
There's bonus marks for each big question. Yeah? There's communication mark.
Oh.
So if you include a lot of irrelevant point, then you lose the marker.
Okay.
Communication marker. And also there's no spelling mistake.
So basically you still have to do all the paragraph. Then you
usually if you can do paragraph, of course do paragraph. Okay. But if you think drawing a diagram can also help you explain. Why not? Okay.
Some question like the phospholipid 直接画一个。
Of course 係啦 ，phospholipid. Or maybe in muscle explain a some section 係啦。好，嚟 40. 40 咧 roots. 咁 in the roots what do we have? We will also have the epidermis from the outer layer epidermis, and then cortex you just need to learn those underlying words epidermis, cortex, and then can you see a word called endodermis? You need to know this word endodermis, and then xylem, phloem, cambium. So where is xylem? Xylem is like in the cross. Phloem is the four corners. Okay, and between xylem and phloem you will find cambium. Okay, and when you look at the electron micrograph, you can see xylem usually are bigger holes, right? And then phloem are the adjacent corners, and then cambium in the middle. Okay. We also need to know that for root structure, they will usually have root hair cell, right? They will have root hair cell. Okay. Root hair cell just like extension to increase surface area for absorption. They will have mitochondria for active transport. We need to learn how to do active transport in our absorption of minerals later. Okay. Thin cell wall, they will have cell wall but thinner, shortened diffusion distance. Okay. Large vacuole. Okay. And then membrane have carrier protein, so they can do active transport easily. And then absence of cuticle. I'm going to try to remember all these important features. We always summarize. Okay. The next page, we start to see a root structure. Okay. For root, also last 2019 November I showed you the picture already.
They asked
the plant So for this topic, but for the plant question, they ask about oxygen, about the growth of plant, the apex meristem. They're about the growth. Okay, so that's why for palm bio usually this year they will not ask you long question. I told you topic 11
But then the 2019 November paper OK 啦，我覺得 final
係 very standard question。
係 same question。
所以咪即係 for high level 咧，you of course one side focus on the high level topics, but at the same time also you make sure you know all the minor things in the SL. They ask a question about Kahn's technique. Do you remember?
咩
Kahn's technique.
就是說
About measurement of length of prokaryotic DNA.
to measure 咯。
How do you measure that? They ask in a short cracker, MC. They can actually change into a paragraph.
Parameter ruler, the scale.
Thymine, you have to mention thymine. Radioactive thymine. ATCGA, Kahn's technique. That's why we should do it. I need to remind you all these that minor things.
我覺得最難的 SL topic is topic 6 other 都
topic 5 topic 5
我覺得 topic 6那個很難，那個
synapse. But topic 5 is difficult.
Really?
Topic 5 evolution.
topic 4咧
Topic 4係 OK 啦，especially you have 咩啊
？ESS
有 PSS 啊嘛
你好
，OK。
担心 yes。
就上次就是因為你說有 ESS，我就沒有問 ecology。
我也沒問。
哦 ，ESS 我都没怎么复习，我上个星期才刚开始复习。
我还没复。
丢8个单元了。
好。
ESS 你都不知道问什么，主要是。
我也是，就是你问完交东西就考完不一样的东西，考的跟学的根本都不是一个东西，这是什么鬼？
主要是背 case study 嘛，we memorize case study。
哎，少，你有没有那种 case study 那种 bank 呀？
哎呀，唔係啦，Mr. Chang 都說了 case study 你就把2個 country 放在一起，他們也不知道了。你就說咩 dolphin 啊 ，in Alaska， 然後就跟他說這裡有個 dolphin， 他又不知道的，他又不會去查的。
好，都係講話啫嘛，屌真係好閪多啊！真係。We even not in the absorption of water yet, okay?
That's 3 days.
頂埋先啊！喂，係喎嗱 roots 啊，嗱 in the roots we have the root hair cell we already mentioned 㗎 ，okay? Root hair cell and can you see epidermis? Can you see epidermis?
係。
cortex 啊 ，first of all cortex 啊 ，okay? Epidermis 係啦，那麼 cortex。And then can you see endodermis? Cortex, endodermis. You need to know this word. Like in the endodermis, there's a word called capastrium band. You can see a word capastrium band. Capastrium band, okay? Now I need to tell you one thing. There's a word called apopause pathway, right? Can you see? Apopause pathway. Can you see this word? Now what is the meaning of apopause pathway? Because in plant cell, water can pass through the space between the plasma membrane and cell wall. There is some space, air space in cell wall, allowing water to pass through from one cell to another cell. Okay? So in cell wall, this is the cell wall, this is the plasma membrane, okay? There is some air space for water to pass through from one cell to another cell. Okay? The water can move in this way. It's called apopause pathway. Apopause pathway is okay? And apopause pathway will not involve the plasma membrane because it will just be air space between the cellulose of the cell wall. Okay? This is called apopause pathway without involving the plasma membrane. It's not osmosis. Okay? Not osmosis. I would say a word called mass flow. Mass flow of water to describe. Okay? We will go through this word later. Make sure you know there's one way to transport water in plant cell through the air space in cell wall. That's called apopause pathway. And we will not use osmosis to describe this type of movement of water. Okay? Because it doesn't involve plasma membrane.
Airspace in cell wall 那不就是
apopause pathway. Okay? Whenever it's involved plasma membrane, we will use the word osmosis. And this time we don't involve, right? Go in and go in on plasma membrane. So don't say osmosis. You can only say mass flow. What's the meaning of mass flow? Just like you imagine you go to a place, so a lot of people are going, okay? You don't need to move, right? The other people push you to move. That's called mass flow. And water now connected due to hydrogen bond. So cohesion push the water to move.
But how can we have gap between cell wall?
Cell wall and plasma membrane, they are not fully attached on each other. There's only 2 air space, right? The water can squeeze through this space to go. That's called apopause pathway. Okay? But when it goes to endodermis, what's going to happen? There is a capastrium strip. There's capastrium strip here, capastrium band here, blocking the water to continue to go. Okay? In endodermis, there's a capastrium band. Can you see? This is the band, this is the band. Okay? So blocking the water to go. So they will force water to go into the cytoplasm. Okay? And then continue to move again. So
continue to move by what?
They will go down into plasma membrane.
They will go down into water.
That it's called symplastic pathway. Have you heard of it? Symplastic pathway. Have you learned this word? Symplastic pathway. Okay? Later we'll go through that word, okay? But make sure you know this word capastrium band. Okay? But then we will go through endodermis again, okay? And then we go into the middle part, we have xylem, we have phloem. Okay? The middle part is the xylem. And then the 5 corners are called the phloem. Okay? Let's see a question. Page 42.
empty 咯。
真的啊？
你講埋佢，咪後面仲有嗎？要 pack。
算啦。
好嚟，快啲。嗱，今日 today we must finish all the structure 啦，就係 root stem leaf 啦 ，OK。嚟 42，嗱 42what is the structure one called? In the stem, structure one
phloem
is the xylem. Structure two is the phloem, because phloem is outside 嘛。OK, one is xylem. OK, two is phloem. OK, in the roots what is four? Four is xylem. Three is phloem.
Hi, 3 is phloem.
Okay, so the question asks you which one is the phloem so I will answer 2 and 3
2 and 3.
OK, 好 2 and 3 we answer C. 好 the next question, 2007. This is a root, right? And then this is the dicotyledonous roots, which indicate the location of cambium. Where is cambium?
Alright, cambium between the xylem and phloem.
So between xylem and phloem, so that is going to be G. Dot. Dot. OK. 明嗎？得 OK。好 the next one. 2007 is the same one, okay? The same question, but it is asking you which one is going to be one. One is the endodermis. C. Okay?
But what's the difference between endodermis and
epidermis?
Epidermis.
Well, of course, it's very different. Epidermis is here. This is epidermis.
Like nuclear envelope.
No, nuclear envelope. Okay. Oh well, next page, 2003. Which one is phloem? Okay, we do it again. Roots and stem, roots and leaf this time. Which one is phloem in roots? 1 or 2? In roots. Which one is phloem in roots?
2.
2. Okay.
One is
and then for the leaf,
4 is phloem.
4 is the 4 is the xylem in the leaf. 一爬嘛。
係，屌你outside 嘛？
嗱，就知 OK 先。
upper or lower, outside or inside
記住 OK 2 3 OK 2 3好嚟 one more the last one stem and root which one is xylem 嗱 masculine xylem this time
4
4 is xylem correct 嘅好 in the stem
2咯
2係啦2 4 B
所以 upper 說的是那個 upper
係啦 in the leaf and the upper 嘅 OK 好嘛好嚟 try one more question next page 218 The 218 you're discussing the stem the root structure okay because you see a cross here right on page 44 which one is phloem tube? Phloem this is roots right? C 啦係啦 very clear C 啦OK 得好咁on this page they ask you to draw to draw the roots okay 咁 you can do it yourself okay dissection of the roots 咁好嚟 47嗱 47咧
draw root 就是畫兩個圈
yes okay 嗱 47 this is a question about how the leaf okay adapted to carry out the photosynthesis okay but this question is not really okay popular now okay so just take a look body and fat cuticle upper epidermis passive mesophyll spongy mesophyll okay for exchange of gases and then they have stomata controlled by gas cells vascular bundle xylem phloem okay you just look at the keywords of this question okay I think you can really describe if they really ask again
okay
low chance okay they ask in 2 or 4係啦Okay, so at least right now we have finished all the structures we finished all the structure like root, stem and leaf, okay? On the next page 51 onwards we are discussing the absorption methods of water and mineral salts. Okay? This is another thing, okay? On the remaining part of this note, this is all about water transport. In the note 2 we will discuss okay, the translocation process of organic food. Okay? Let's see, okay, page 51 Now 51 we want to discuss a bit okay, about absorption of water and mineral salts in the roots. Okay? In the root you know that we have wood hair cell. Wood hair cell have long extension to provide large surface area to bone ratio to facilitate the absorption. And then the cell wall is thinner, we mentioned before, not covered with cuticle. And they have a lot of mitochondria to provide energy. These are the main features for the wood hair cell to absorb water and mineral salts. Okay?
Mr. Brown. So, 放在那个 macro picture. So xylem and phloem 就是在 all the way goes up and all the way
yes.
everywhere.
Okay, maybe I show you a picture if you want to see the connection, right? Of stem and leaf. you can look at page.
Also from the root cell 都係晒喺度
係。page 77啦，好嘛 ？77。Okay. 77 or 76 this is the page, okay, showing you the connection from the roots to the stem to the leaf finally. Okay, can you roughly imagine, okay, in the root we absorb, right? And then passing into the xylem of the roots, and then passing to the xylem of the stem, right? Keep going up, and then finally go out to the xylem of the leaf.
The leaf.
And then the water can replace those water loss due to evaporation of the mesophyll cell. Okay, 係嘛？好，咁we go back to 51. We just want to discuss a bit about the roots. Okay, how does it adapt to the absorption? Page 52 adaptation for the root part for the plant root for absorption of mineral ions for the mineral ions usually we focus on one method to absorb by active transport by active transport. And to carry active transport, they need to have proteins, right? Carry proteins. So we need to have a large surface area with branching. Okay. Now the white hair cells contain carrier protein, for to have the mitochondria, okay, to provide energy for carrier protein to work. So we are just discussing two important features.
So carrier protein
large
is
surface
for
area.
Minerals.
For absorbing minerals ions into the leaf, okay, by active transport. So in order to hold more carrier protein, we need a large surface area to formation. So that's why it needs to be branched. So this is the paragraph discussing absorption of mineral ions, okay, from the roots, and we need to discuss a bit about the adaptation, the structural adaptation.
Okay.
54 55 we discussed the last part up to here 54. If now, okay, we know how to absorb, okay, the roots what is the structure of the root, then now we're going to learn how to absorb water, how to absorb mineral source. Now if you talk about absorption of water, must be by osmosis. First of all, it must be by osmosis from high water potential outside the roots into low water potential in the roots.
But then when do we use osmosis? When do we say diffusion?
No. First of all, water must be usually by osmosis.
Okay.
And remember, when you mention osmosis, you have to say full partially permeable membrane. That means full membrane. Okay, osmosis must be full membrane. And right now, to create a lower water potential inside the root hair cell, we need to make it saturated with a lot of salts, a lot of ions, right? In order to create a higher solid concentration inside the root. You still remember osmosis definition, low solid to high solid. So how to make high solid inside the root? Active transport, pump the ions into the root. Okay. This is the process of water absorption by osmosis. And we are now going to talk about how to create a high solid concentration inside the root. If you talk about mineral salts absorption, you can by some method get diffusion. There are three methods, okay? The first method you can say here, you can write down mass flow with water. The first method is mass flow with water. The second method is by diffusion. Of course, the diffusion method is by facilitated diffusion. The ions cannot go in, right? Cannot be going through the phospholipid bilayer. It must be through channel protein. Okay? Then the next method is active transport. So we will have three methods for the mineral source to be absorbed. Okay? At the bottom paragraph, I'm elaborating the third method. I'm elaborating the third method in details. Okay? We have three methods. I will elaborate the first one and the second one later. But for the third method, we discuss a bit first. Okay? What type of ions do we need in the plant? Magnesium ion for making chlorophyll, nitrate for making amino acids. We have positive ion, we have negative ion to be required by the plant. Okay? And how do we transport the positive ion? Say for example, we first of all bump hydrogen ion outside first. We bump hydrogen ion outside. Okay? Bump hydrogen ion outside. Then right now there's a space, right? Like you can imagine. We're going to bump hydrogen ion outside. And then some sodium ion, see, there's a lower gradient, right, for positive ion. So sodium ion can be taking the place now. Okay, or maybe potassium ion, or see there's a space, right? There's a lower positive charge gradient, right, inside the cell. So they will go in by facilitated diffusion. Okay. You are actively, right? Actively bomb the proton bomb. This one is full proton bomb. You use energy already, you use ATP to bomb the hydrogen ion outside, okay, to create an empty space, right? So the positive ion can go in, can take up the place, okay? But overall, we still say active transport because it used ATP already, okay? The next one is the second way you can imagine is, the hydrogen ion is bombed out, proton bomb. After I bomb the hydrogen ion outside, okay, I have now some negative charge ion to go in. Okay, say for example, we have a nitrate. Nitrate ion wants to go in, so it will be combining with hydrogen ion together to go in. Positive charge attach negative charge, right? So that they can move together. Okay, do you understand? This is the meaning of active transport. Both process has used ATP, right? So we will discuss those methods at active transport.
We bump out hydrogen.
Bomb out hydrogen ion, proton bomb. Sodium ion, positive ion can take place, right? Can go in, right? By going back to the space originally occupied by hydrogen ion.
Yes.
But negative ion, how can they go in? Okay, they can bind to hydrogen ion, and the hydrogen ion can go back together, right?
That can be wrong.
Okay, so depends on the charge of the ions.
That's how we absorb mineral.
Yeah, this is how the part absorb mineral by active transport.
Why do we need magnesium for?
Magnesium make chlorophyll.
For chlorophyll. Why
Make chlorophyll. The chlorophyll. In the middle, there's magnesium ion. Okay.
Okay.
Alright. Do you understand the meaning of active transport process?
Okay.
On the next page, we have a paragraph to summarize. Describe the process for the absorption of the minerals from the soil into the root. So first of all, absorb minerals in ionic form. Give me some example. And the branching of the root hair cells, they can enhance the absorption. Yeah. Okay. Majorly, you give me some adaptation. Mitochondria. This is important adaptation. Okay. What are the methods? We discussed the first method, mass flow. The mass flow with water. What do I mean by this? Because the ions are soluble in water. They're ionic, they're polar, right? They dissolve, they're hydrophilic, they dissolve in water, move together with water by osmosis into the soil. They move together with water. They dissolve in water. Mass flow, let ion go in. Alright, the same method is based on facilitated diffusion. Maybe some ions is high concentration outside the wood hair cell. Then they can go in by facilitated diffusion. Okay, this is a long concentration gradient. And then the third method is by active transport. So we just mentioned by active transport. Of course, all these are dependent on the concentration gradient. Yeah. So if you rely on this method, I mean on the previous part, here, on the previous part, you can tell sodium ion, potassium ion, nitrate ion are moving against concentration gradient. Sean, here.
Hi.
When you talk about this arrow, these are against concentration gradient. These are against concentration gradient.
Right.
Okay, not only just mention proton bomb, okay, using ATP, we also talking about these ions. These ions are moving against concentration gradient.
Do we need to use the ATP for active transport?
We have already used ATP here. You have already used ATP from the hydrogen ion. But I want to let these ions, potassium ion, sodium ion, nitrate ion to go in. But this time, unluckily, they are against concentration gradient. Okay? Do you understand?
So we have to get the...
These ion against concentration gradient.
So we have to get the proton out of the first.
So how do I move them in? We are using hydrogen ion. Hydrogen ion bomb out first. And then these will be moving in.
So this is actually active transport. They actually pass through some protein bomb.
Yeah, of course they will be full protein, through the membrane protein. Okay, we just draw a very simple diagram.
Okay.
I want to say if I'm using this way of transport, they are usually against concentration gradient.
Yeah.
If they are a long concentration gradient, why do I need to do so many processes?
That's the second way of doing it.
That is a long concentration gradient through channel protein, right? facility diffusion 咯。
How can we do mass flow? Isn't the same as the
mass flow is just you imagine your ions, okay, you're surrounded by water molecule. Because you can be soluble in the water 嘛，係嘛？ You are surrounded by water. When the water go in, you also move in.
It's the same as the the hydrogen proton uptake.
How do you uptake?
Like they bond with that.
Oh yeah, it's similar to this process. The hydrogen ion, similar to this one, but this is water, right?
Okay.
The whole circle is water. You are the ions inside. So when the water go in by osmosis, you also go in. Okay, that's the meaning of mass flow. Okay, facility diffusion and then also active transport 啦，得嘛？Gains concentration gradient. So we can say carrier protein bump out hydrogen ion，係嘛？Positive ion diffuse into the root 啦 ，negative ion 再 link to hydrogen ion move in。
Easy。
係啦 ，OK， 明嘛？好咁啊嗱 ，for the second part is about uptake of water 啦。So the major method is by osmosis 啦，係啦。咁 the first paragraph is just describing how to create high solid concentration.
So then we have high solid concentration. We use osmosis.
Yeah, we always keep bumping in, 係嘛？得嘛？
So mass flow with water is actually in the osmosis.
Yeah, osmosis, yes, it's definitely. But okay, like even 即係 inside the wood hair cell， 嗱即係 you imagine, even right now in the wood hair cell, we have a lot of that type of ions. We still keep doing active transport. Why? Because I want to create a very high solid concentration. Then water can go in by osmosis. That's why you understand the meaning of active transport so important in the minerals absorption. Okay, so we seldom focus on the first two, right? But of course, the first two mean mass flow and facility diffusion, important. But active transport is far more important because this can create high solid concentration to let water in by osmosis.
Where do we get the hydrogen proton?
The cells will have hydrogen ion 嘛。係。Without hydrogen ion, how can the plant cell carry the? Think about how to produce hydrogen ion. Photolysis of water 啊嘛，係咪？係嘛 ？There must be hydrogen ions surrounding.
Photolysis of water.
係 produce hydrogen ion 啊嘛。
And photosynthesis also produce hydrogen ion.
But photosynthesis is light reaction. Photophosphorylation, photolysis of water. Photolysis of water produce hydrogen ion, and the electron replace photosystem electron loss.
Hydrogen goes to the.
You have a lot of hydrogen ion.
Hydrogen is the waste product.
You have a lot of hydrogen ion, so don't worry about hydrogen ion. It's okay. But do you understand why when we mention a lot of active transport for water transport? Okay. Osmosis, okay. And then the next two paragraphs is just to describe how to move the water after water absorbed into the plant cell, into the plant wood cell, wood hair cell. Okay. 對嘛？咩 apple pathway 啦 ？We'll go through this later. 對嘛？好嗱 ，just a few questions 好冇？我 57 the first one 啦。喂 ，how do mineral ions move to the root through the soil?
Translocation.
The translocation is about the forward movement. 對嘛？ The solids, the beyond mass flow. 係嘛 ？This is one of the best way. Mass flow, facility diffusion, active transport 啊嘛。How the water molecule enter roots must be by osmosis 啊。Osmosis, okay. 好的 217 啦。How the causes responsible for water uptake by roots? The water uptake 啊嘛 ，so must be by osmosis 啊。Solid concentration in the roots is greater 啦，係咯。So high to low to high solid concentration. The 2003 what is the uptake of minerals? 嗱 ，OK ATP require 係啦，嗱 if ADP require 就 require the membrane protein 啦。OK 咁 against concentration gradient 嗰邊咯。OK 好 the last one 啦 216. Excessive irrigation that means you have put a lot of ions 係啦。So in the soil it's so much
decrease the osmosis rate.
Decrease the osmosis rate because do we have this absorption of water with a high decreased water movement from soil into the root 係啦 yes 咁啊 OK
So gradient is hard to create.
係啦咁啊
So smart.